Hello, welcome to our channel for R programming. In this video, we will talk about tests for independence of errors in linear regression using R. So we know in linear regression model, one of the assumptions is the independence of error terms. Now, this is same to say the dependent variable values are independent from each other because the dependent variable value is linear regressed with the fitted model plus the error term. So this is same as to say the error term or the residues are independent from one another. And we cannot test the independence from each pair of residues, right? Because there's only one item, one residues. But a general test for the independence of residues is to test if there is type of autocorrelation. So autocorrelation can be tested usually using a so-called Durbin-Watson test. Durbin-Watson test is to test if there is one leg correlation between the residues, or say one leg autocorrelation. In R, we can use function called Durbin-Watson test from car package and test the result of a linear regression model. So next we will show how to do this in RStudio. So first we load the library called car. You have to install this library if you have not done yet. Then we create data frame called states. Actually, this data frame contains 5 variables from a data frame called state.x77 from R framework. So you can see this data frame includes each state of America with the variables murder rate, population, illiteracy, income, and frost. So next we establish a model called fit. This fit model is the result of the linear regression from dependent variable murder and with the independent variable with the first power of this independent variable, population, illiteracy, income, and frost, and with the data frame states. So we just run this. So the model is done, and next we can use Durbin-Watson test for this model of independence of residues if there exists autocorrelation. So we run this statement. Now the result is quite simple. This is called leg 1, and autocorrelation has a statistic and also a Durbin-Watson statistic. Then the p-value is 0.256. So this is the important value we have to focus on. Though you can see the alternative hypothesis is a rho not equal to 0. So this rho is the coefficient between the residues if there exists autocorrelation. So if there is autocorrelation, or there is one leg correlation between each pair of residues, so there exists a rho coefficient not equal to 0. So we get p-value 0.256, which is significantly larger than 0.05. So the result is not significant, and we will hold the null hypothesis, which is to say the rho is 0. So if we get the p-value, say very small, smaller than 0.05, then we will favor this alternative hypothesis, which means the rho is not 0 and there is autocorrelation. But in our sample data, the test is not significant, and we will not reject the null hypothesis, and we will hold to say that there is no autocorrelation, or there is independence between each pair of residues in our sample. Thanks for watching.